Hello everyone, and in this video I am going to talk about the compilation and interpretation process, whatever happens whenever you write a Python program. This tutorial is all about how any particular Python program works. So let's continue from here. So all of us know that Python is basically an interpreted language, right? But what does that mean? Does it mean that no particular compilation process happens at all in Python? Nothing as such, right? Whatever code you write that does undergo a compilation process, there is a compiler component that is being involved for the sake of converting your code to an intermediary phase of code, what we call as the bytecode. Correct? Where I can basically find the bytecode of the code that I have written inside the Python programming language. So whenever you execute the code, right, basically a PyCache folder gets generated. Here we do have some files with the extension .pyc. They contain your respective bytecode. Correct? Okay, fine. If you want to see how the bytecode of a certain Python program looks like, let's try to proceed ahead with a real-time demonstration. So here, this is my PyCharm ID where basically I've written a simple add function. So in order to generate the bytecode of the add function, you can utilize the respective dis module, whatever is inbuilt in your Python programming language. Corresponding to this dis module, inside that you get basically a function. Again, the name of that function is dis. You say that whatever add method I have written inside the Python programming language, generate its bytecode. So the overall bytecode corresponding to this add method, it would be looking like something this, right? You are getting some sort of load fast twice commands like this. That is basically trying to load the values of the variables a and b, whatever I'm accepting as a parameter inside the add method. Proceeding ahead with that, you are getting a plus sign that determines that, okay, what should be the result basically I should be getting if I try to add the values of a and b, and after that, whatever basically the value of addition we got, just return that. Correct? Now, let's try to analyze basically based on this specific bytecode that has got generated, right? How overall basically that gets executed. So yes, whatever these bytecodes are, right? Load fast twice. So basically these are being determined in terms of stack operations. Internally in Python, all these bytecodes are being executed in terms of stack operations. Whatever load fast first instruction that is being present here. So corresponding to this, the value of A would be the first one to get loaded onto the stack. Corresponding to this, the second instruction, whatsoever is there, right? Load fast, and after that, the command B is coming. Here, overall, the value of B is going to be loaded. Post that, you are getting the respective binary operation that is determining for us that try to perform some addition based on the operator plus. So corresponding to this, both the topmost values A and B, they would be extracted from the stack data structure. Finally, whatever the addition result you have got, that would be calculated, and that would be the final thing that would be pushed into your stack internally, what is being maintained. And finally, this overall value would be extracted and returned from wheresoever the method has been called. This is how, in terms of simple sort of explanation, I can try to say your overall execution of bytecode happens. But who does this execution, right? Who does this execution? Generation of bytecode is being taken care by your compiler, correct? But who executes this bytecode? So see, whatever overall we have seen in terms of your bytecode so far, this is not a machine code. Any of the bytecode instruction you have seen here, this has nothing to do with the sequence of zero ones, right? Whatever directly my CPU can execute, whatever your CPU understand, this is basically the binaries. Apart from that, it cannot directly execute that. So in order to execute a bytecode corresponding to Python programming language, you would require something called as a Python virtual machine, correct? And bytecode, whatsoever it is that has got generated, that would be passed on to your respective Python virtual machine. Basically, your bytecode loader, a component of Python virtual machine, is responsible to load any specific bytecode that is getting generated corresponding to a program. And the task of another component interpreter that is inbuilt inside your Python virtual machine is to convert the respective bytecode instruction to stack commands, whether to add onto a stack, whether to delete onto a stack, how many values to be popped from the stack. All these things would be taken care by your respective interpreter component. And post the stack operations command has been generated out of your bytecode instruction, these execution of stack operation would be taken care by your execution engine. Again, this specific component is present onto your Python virtual machine. So in short, we can try to keep how overall your Python program gets executed. It does get compiled, but there is an intermediary phase of what we call as the bytecode that gets generated by the help of a compiler. Okay, so basically, see, another thing I would like to discuss is that where do all these components are being present? So overall, I would be saying that there is a runtime environment, whatever is required for the sake of keeping a compiler component alongside the Python virtual machine. Most common runtime environment, right, is C Python. Whatever is being default and inbuilt corresponding to any Python version that you install onto your machines. There are other ones as well, just like PyPy. How overall CPython and PyPy are different, I can discuss that onto the next video. But yes, in order to execute a Python program, right, you would require this specific runtime environments, and they come inbuilt in terms of CPython corresponding to any version of Python you are installing. Another thing that I would like to discuss here is that whenever you are basically generating the bytecode, this specific bytecode is machine independent. Okay, this is machine independent. Now, what does that mean? It simply means that if any bytecode B has got generated onto the Linux machine after the compilation process, right? The same bytecode I can transfer to a Windows machine as well without any sort of recompilation. Whatever result has got generated from Linux, let that be R, same result after the execution from a Python virtual machine without recompiling the existing bytecode, again, I can try to regenerate onto a Windows machine. Fully possible. Vice versa is also true. Inside a Windows machine, if you generate the machine independent code or the bytecode, you can transfer that to a Linux machine. All the Linux machine requires is a Python virtual machine in order to produce the exact output, whatever already has got generated onto the Windows. So no recompilation process is required at all. So this is all about a little bit of how Python programs internally gets compiled and interpreted. If you liked the video, please like, share, and subscribe. And you can comment down onto my channel what more kind of videos you want. I will try to come up with a short and concise explanation of everything. Thanks all. Please support my channel by subscribing. Thank you.